the empirical rule, which I need to unfreeze the screen here for you to see. So here's the notes for 5.4. We're going to do the first part, get a little head start on Friday's lesson. So 5.4, the empirical rule, also known as the 68, 95, 99.7 rule. Because remember how when we were looking at the data yesterday and we found out that, oh, these two students, even though their data was very much different, within one standard deviation, they both had kind of the same number of test scores. Does that make sense to everybody? You all remember doing that? Like the two students, student 1 and student 2, both had 5 test scores within one standard deviation. That's based off of this, the empirical rule. The empirical rule says almost all data should be within 3 standard deviations of the middle, of the mean. More precisely, 68% should be within 1 standard deviation. So about 2/3. 2/3 of your data should be within 1 standard deviation. 95% should be within 2 standard deviations. And 99.7% should be within 3 standard deviations. So almost everything. Now, this is an average. It's not perfect. But what that looks like here, if I go 1 standard deviation out, have you all seen bell curves before? Some of you, yes, some of you, no. A bell curve happens when you have what's called a normal distribution. And you can even get bell curves where it's not a normal distribution, but similar. A normal distribution is where you have most things falling in the middle, and the farther away you get from the middle, the fewer people, things, items, whatever that match up with that. So height is a normal distribution because maybe we have an average of like 5'8", 5'7", somewhere in there. If that's your average, let's say it's 5'7". Then as you go out from there, you're going to have a lot of people that are 5'6" and 5'8". Still going to have a lot of people that are 5'4" and 5'9". But the farther away you get, the fewer people you have that are that height, until we get to like 6'5" and 4'8". And we have very few people that are that height. Does that make sense? The farther away you get, the fewer that we have that meet that value. That's what makes this bell curve shape. So the idea is within 1 standard deviation, we have 2/3 of our data is in there. If I go 2 standard deviations out, it's 95%. 3 standard deviations and it's almost everything. Just the little tails on the ends that are not counted. So it is only an approximation. It's a quick way to figure out whether data is normally distributed or not. And we're going to use it to help kind of approximate how much of the data or how many people or how many items should be in a certain range. You are going to have to memorize either 68, 95, 99.7, or the numbers I'm about to show you. Turn to the next page. We're going to distribute, or we're going to label this graph. We're going to label this graph with the percentages based off of the empirical rule. So I'm going to split the graph in half right now. Here is my mean. X bar or mu, it's the average. So 50% above, 50% below. Does that make sense to everybody? Average is right in the middle if it's normally distributed. If I go up 1 standard deviation or down 1 standard deviation, right? That's what that symbol means. The little circle with a tail is standard deviation. So up 1 standard deviation or down 1 standard deviation. This section right here, this should be 68%. Class, what's half of 68? 34. So this piece right here should be 34%. And this piece should be 34%. Now, the empirical rule says if I keep going and I go to -2 standard deviations or +2 standard deviations, that should be 90, what is it, 95%? Make sure I'm remembering the right one. Yep, 95%. What's half of 95? Use a calculator. What's half of 95? Is it 47.5? 47.5. What's 40? Okay, again, don't leave your calculators yet. What's 47.5 minus 34? This piece right here should be 13.5%. And so should this piece. Now we're going to go one more out. 3 standard deviations. So plus 3 standard deviations or minus 3 standard deviations. That one's supposed to be 99.7. What's 99.7 divided by 2? $49.85. What's 49.85 minus 47.5? What we've got so far. 2.35. Bless you. This piece right here should be 2.35%. And so should this piece. 2.35%. And then what's left over? If I have 99.7%, what's left over? 0.3. Does that make sense to everybody? Cut that in half. And the last little pieces, the little tails on either side, this piece right here should be 0.15%. And this piece right here should be 0.15%. This graph, everybody's full attention right now, hopefully. This graph is always the same. Those percentages do not change. So you have two options. You're either memorizing the 90 or the 68, 95, 99.7, and then figuring out how to do this, or just memorize this because this chart does not change. Yes. So you've only got about 5 minutes. If you got to go, it's fine, but you might want to stick around and watch for this. So now the idea is copy this down. Every time you're doing this, it's the same percentages. The only thing that changes is the bottom axis down here. You're going to put the average. So the average here, the mean is 75. That goes in the middle. And then it says the standard deviation is 5. So I'm just going to count up and down by 5s. 75, 80, 85, 90, and counting down 70, 65, 60. With that information, I can answer all these questions down here. Part A, what percent of scores are between 65 and 75? So here's 65, here's 75. In between those is 13.5 plus 34. 13.5 plus 34. Is that 47.5? There you go. 47.5% is going to be within those two boundaries. What percent of scores are between 60 and 70? Here's 60. Here's 70. Add those two together. 2.35. Sorry, let's not erase my little work there. These two added together. 2.35 plus 13.5. Yeah, what was it? 15.85? Now, what if they ask me for the actual number of students? So between 65 and 75. I already know the percentage, right? 65 and 75, we said was 47.5%. So I know this is going to be 47.5%. But they want the number of students. So I come up here and I look. It says there's 2,000 students. So I'm going to find 47.5 out of 100 is how many out of 2,000. And I'm just going to calculate what's 47.5% of 2,000. Do you guys see a fraction equals a fraction? What do we do when you have a fraction equals a fraction to solve? Cross multiply. Right there. Equals there. 2,000 times 47.5 is 95,000 equals 100 times x. Divide by 100. 950, a little bit less than half. 950 students. Does that make sense to everybody? You just learned the first half of section 4. Okay, it's not too bad, providing you can memorize these numbers or you can find them from the empirical rule. There's one other piece of section 4 that we'll do on Friday. That's z-score. It's maybe even easier than this.